Why do you think?
I know why, because like almost every single student chose cooking.
I think that's a coincidence. That's not why. I didn't hear that.
Over 90 students chose cooking.
Cool. Sweet. I'm not cooking. All right, here we go. No, I am cooking, just for the record, but in a different sense.
It's supposed to start today, right?
It was going to. Anyway, here we go. We are going to start today looking at our chapter 3. And in chapter 3, we will focus on a single overarching theme, which is the idea of transformations. Now, if you guys didn't hear it, and everybody's here, so nobody's probably watching the video, but somebody in class just groaned audibly. It should have been Lily, in my mind, because we did a lot of transformations in algebra, and people don't seem to love the transformation stuff that we did there. Left, right, up, down, vertical, stretch, compress. You were apparently okay with it, which awesome. Very different here. Okay, when we talk about transformations, we're going to jump right in. I don't want to name the first one yet, but if I say the word rigid, what do you guys think? Sharp. Like a ridge on a mountain, I imagine. That is always throws me for a loop because that is nowhere near where my head goes.
I think of frail.
You think of frail. I think it's the exact opposite. Something that doesn't change. So like the rules, I try to be as rigid as possible with my rules because I want to be fair and I want to do the same for everybody. And of course that changes, right? Like it depends on the situation. But we are going to be looking at some rigid stuff, which is just no change. Like that's the important idea. Don't think of a ridge of a mountain. That's a different R-I-D-G-E. We are going to do R-I-G-I-D, rigid, which is unchanging. So like a piece of metal is, if it's not gold, like a piece of steel is rigid because you can't change the shape, right? Not without doing a lot of work to it. Okay, in 3.1, following our bell ringer, our focus is on one particular type of transformation that we're going to try to play around with and see if we can't make sense of, and I'm just going to write it. We're going to be talking reflections. Okay, now we're going to see a few more of them as well, but our very first topic here, just to make sure it kind of lays the whole foundation for the next several sections, the very first thing within 3.1 that I want us to think about and have is a true definition of what it means to have a rigid transformation or a rigid motion. Now, your book refers to these as motions, and I don't know why my eyes have serifs all of a sudden, so I'll put them on here too. Rigid motion. Now, I would rather use the word transformation, but I'm also lazy. So motion is the word that they use. I think of these as transformations, and I think we can get the same idea just by saying they are rigid transforms. We're moving something, transforming it. Okay. Now, very specifically, there is a huge difference in the types of changes that we can make to something. So check it out. I have a circle, and I'm holding a circle in my hand. Okay, I'm not going to change the shape of my hand, but it's a circle, right? Everybody see a circle there? Okay, I moved the circle. Did I change its size or shape? No, what if I, instead of doing that, what if I reflected it all of a sudden? Did that change its size or shape? So everything that I'm doing right now is just changing its location, but nothing has actually changed about it, right? Okay, what if you were thinking about the circle that I want to think about is our eyes? And this is going to seem like a weird question. Have you guys ever looked at your own eyes in the mirror and flipped the light on and off? If you haven't, do you know what happens? I have too, Vincent. I've done this a lot of times in my life.
It looks like your
Yes,
face is
I have,
like
actually.
melting.
Oh, absolutely I have. Okay, so you guys might think that's kind of a weird thing to do, but I don't think it is. If I had a concussion or a suspected concussion, would a doctor shine a light in my eye?
Yeah,
Why?
because it dilates your pupils.
It dilates your pupils. What does that mean?
It makes them get bigger or smaller.
Bigger or smaller? Has everybody seen a pupil dilate before?
Yes.
Have you never seen it, Ashley?
Thinking
So check it out, and I'll just show you guys right now. I don't know if I can do it on there, but right now I have pupils. I'm pretty sure. Okay, you see my pupil? How big it is? Now watch what happens. Is it changing size?
Yeah.
It dilates. It does that all the time.
No, I hate
Constantly.
dilation.
Okay, Well, the good news is you don't, you won't, but we're not doing dilations today. Okay, what's up? Okay, so pretty cool. If you've never done it, you should do it like when it's really dark. Like go into your bathroom sometime if you're mirror and light switch. Like turn off the light, let your eyes get really big. Like your pupils get really big when it's dark. And then get really close to the mirror and turn it on and look, and you'll see your pupils go from this to like zoop, and they'll like super quick. It's weird. Can't believe you guys never done that. Or me and Vincent are the only cool guys here, so that's okay. All right. Well, good on you. You're welcome to the Cool Guy Club. Cool Person Club. Ladies, you can be in the Cool Guy Club too. Cool Person Club. Sweet. Rigid motion. Let's define it. Okay, all this means is no changes to lengths or angles. No change to length. No change to length or angles. I'm going to call it lengths because it could be many sides or angles. Okay. I can take a square and I can spin it and it's still the same size, same shape square. Nothing has changed. If I dilate it and make it bigger like my pupils did, it's still a square. It might have the same angles, but the side lengths have definitely changed. Those would not be rigid. We are only looking at rigid right now. Now, specifically, I've already given you one of them. I just want to see if we can come up with them. We look, and I think that, not think, I'll tell you with certainty that reflections in general are rigid. Check it out. I have two hands. And hands don't really work that well because they don't look the same on both sides, but we're going to pretend that my hands are the same on both. If I have this hand, and I have a line right here, and I reflect it, does it still have the same shape and size? Yeah, I haven't changed anything. Is there another type of transformation or movement that would not change the size or angle? Ooh, a translation. That's a fancy word. Can you give me a synonym for it that might make a little bit more sense? Or tell me what a translation is. Either of those.
It just moves it up, down, left, right.
Good. It's just moving it left, right, up, down, diagonally, whatever combination of them. So that also doesn't change the shape and size. Like, check it out. I'm me. Now I'm still me, but I've just been translated about 1.5 meters to the right. Cool. Piece of cake. Right. Rotation. Right now I'm me. Am I still me? Like my shape has changed here, right? Because I'm changing. But if I could spin just my head, then it would still be the same size and shape. Awesome. Reflections, translation, and rotation are the three basic transforms that we'd call a rigid motion. Now, nice little language here. I'm going to write this in purple. It is entirely up to you if you want it. I will not ask you about this word, but there's a very specific math word related to this. If we have a rigid motion, alternatively, instead of just calling it a rigid motion, these things can commonly be referred to as isometries. If things are isometric, same shape, same size, and these are just movements that preserve that. Okay, I will never ask you about this word, but it's there, it exists, it's a real word. Cool. Okay, so right off the bat, we have a weird situation because I want to try and just quickly, all I want to know, not specifically what sort of change has happened, but I just want to know, is this rigid? And I legitimately think I'm going to use Microsoft Word to help me with this. Okay, maybe not, because you guys won't use Word either. So check it out. We'll give us an easy one. Here's a lovely triangle. There's another lovely triangle. Now, we can't really tell just from the picture, can't tell which one we started with and ended with. And this is where it's going to get weird just based off of having to draw them by hand. Are they both triangles, first of all? Now, we're not going to go measure the angles and stuff. Do you think they're the same triangle? Or I was trying to be at least the same triangle. Now, looking at this. This, I am tending to draw a rigid transformation here. This angle here looks like it would match up with that one, I think. This angle here would match up with this one. And it seems that that side and that side and that side and that side also match. Now, I didn't do it perfectly. I just drew it out. I tried to do it. This is a rigid transform. Now, I'm just going to state, first of all, our answer, yes. But we're going to sneak in a little bit of vocab in here without having to be crazy wordy. Do you guys agree that those look the same shape, same size, just different?
Yeah.
Okay. what I was talking about with Microsoft Word, I'll show you guys because I'll actually give us some really nice, realistic ones. But with this, you can't tell if I started here or here. Do you think this was a rotation or reflection or translation? It certainly looks like a reflection to me. I think it was probably reflected over this line is roughly what happened. Okay, if we look at this, regardless of whether we think it's a reflection or whatever, that's not our point. Let's say we started here. This is our original, and we did something to move this original triangle to this one, and I'm going to call this one the new. Now, these are really informal words right now. It's possible that it gave us this one, and I just reflected it, and I got this one. Cool. Maybe there's other things. There's not in this case, but there could be other situations where I could rotate to get to the same place, whatever. Okay, the real formal language. I'm A-okay with original and new. Like, that's way more common to make sense of. But the real formal language for this is that we have what is known as the original is actually called the pre-image. And if this is the pre-image, once we do some sort of transformation, any shot in the dark of what we might call post is a good thought, but you don't even have to go that far. Pre and now image. Carson, I wish that it was the way that you wanted it to be because that makes more sense in my head. Pre-image to post-image, but we have a middle step as well. Okay. Yes, ma'am.
Couldn't you also like do like A, B, and C for your original?
Guarantee we are about to do exactly that here in just a minute. Yep. Do you remember using apostrophes?
Yeah.
Yep, we're going to do that. Exact same thing. Okay, one more. Just real quick. Here's a lovely square shape or diamond shape. I don't know exactly what it is. And here is my attempt to draw the same thing. Are these the same shape?
Yes.
Okay, they both foregons, and I've tried pretty hard to make them have the same angles. Whether or not it's perfect, I don't know. Probably not. Was that a rigid transform?
No.
Why not?
It changed its size.
Well, gosh darn it, my side length changed. It's not rigid. Like, it's that easy. Now, it won't always be that easy. Based on the bell ringer today, what we were seeing with their faces and the weirdness on some of the faces, were those rigid or non-rigid transforms? We didn't change any of the shape and distance. It's exactly like this, which is what made it so weird, because real people have an ear that's a little lower or higher. We just moved everything exactly the same. Okay, now, as we go through this, these are just examples. This one, if I went from here to here, I'd certainly change the size, and it's not our focus today, but that's called a dilation. Do you think I translated? Did I just slide it and then change the size? Did I rotate it? Did I reflect it? Or can you not tell? You can't tell. I think that it's completely reasonable to think that this point went to right here. Maybe I just translated it and then I made it bigger. But I could also have rotated it about some particular point, maybe here, and just rotated this point all the way down to here. Like, there's a lot of variations that could have happened. Don't care about which variation it was. All I care about is that this is non-rigid. So rigid, the answer is no. Okay. Feel all right with that? Cool. Well, let's get a little bit more in depth. So we have this definition, this working definition that we'll keep adding to. This is our focus today. So let's go ahead and give ourselves a new topic. Andrew, there's no right or wrong answer. What color is a reflection? There is a right answer to this, just so you know. You can give me any color, though.
Blue.
Blue. Okay. You guys want to know the right answer to what color is a reflection?
Green.
It's green. Mirrors reflect a slight green hue that our eyes don't pick up, but mirrors are green. Cool. All right. So here we go. We are going to dive in and look very specifically at reflections. And we're going to sneak this in as a definition here as well. And there's a few different ways that we can think about them. And I want to make sure that we'll all agree on the natural one, I think. Reflection. Okay. I'm going to make it reflections. Now, I understand all the math and all the physics that goes into mirrors and stuff. Did you guys hear something? I still can't make sense of a mirror if I'm standing in it. Like, I just can't make sense of it. And I don't know if you guys have ever experienced this, but we all know that if I look in a mirror If I hold up my right hand and I look in the mirror, he's not holding up his left hand. Right? We've all seen that happen.
Well, he's holding up his left.
Yeah, he's holding up his left hand.
It's funny how we're talking about it as if it's not you.
I mean, I don't know that it's me. I've never asked. He's never answered. But in my head, it doesn't click. And maybe you guys are the same, or you guys are gonna be like, oh my God, Holloway's an idiot. That's okay. He's holding up his right hand, or I'm holding up my right. He's holding up his left. And then I turn a little bit, and he's still holding up his left. I turn a little bit more, and he's still holding up his left. But there's a magic point where I do this, and all of a sudden, he's holding up his right hand. Like, it just switches, and my brain can't connect it. Like, I can make sense of a mirror image as I'm looking at it, but just the physical act of, if you've never done this, I would encourage you, stand in front of the mirror, hold up your right hand. Have you guys done this ever? Never? Should we take a trip over there so you guys can go to the bathroom, we can look at it and just see it? Okay, I wish we had a mirror that we could all look in, but this is what we're gonna do. We're gonna go get a drink of water. You guys are gonna walk in the ladies' room, and we'll walk into the boys' room, and we're all gonna look in the mirror and go, hey, guy, you're holding up your left hand. And you just slowly turn, and you'll be like, hey, wait a second. I didn't change my hand, but you did. So, reflections. The good news is we don't have to look at mirrors. For this, there's a few different interpretations of what a reflection might do. Okay, one of these, I'm gonna use a very algebraic approach. The first way that I wanna think about this is a reflection is simply a mapping, and we'll make sure we make sense of that. A mapping, and I'm going to underline that, and we'll come back to it. It is a mapping where each point on the preimage moves to a point on the image. Now, when we're looking at this mapping idea, I have a very specific notation that I like to use, and it has made it so much easier to, one, grade, but to make sense of and find mistakes that I'm going to introduce here in a second. We have a mapping where each point on the preimage moves to a point on the image. Okay, additionally, a little bit more. Specifically, something very important happens. The perpendicular distance from point to line of reflection to the line of reflection is constant. Now, we'll see what that really means here in just a moment, but we have the distance between whatever it is that we're reflecting and the line that we're reflecting over. It is kept constant or preserved.
Is that perpendicular?
Perpendicular. Yep, the perpendicular distance. Now, to help us make sense of this, we are going to do a couple little graphs. If you'll take a piece or two, we can do a couple examples on one. We just take a piece of that and pass it over. I would say on this graph paper, try to do two different pictures. Like, we'll do at least two of them. Now, as we look at it, we have this whole kind of ugly definition, which maybe you don't love the wordy version of math, and me neither, to be honest. But let's look at one very specific. And this is less of an EG, or less of an example and more of an EG. But I'm also going to grab a piece of that, and I'm just going to do it on that instead. If you're going to use graph paper, sure. Yeah, you're good. Thanks, Ray. Cool. All right. Now, here's what I want us to do. We do not need to have a coordinate plane or anything written yet. We'll get there. However, for this first one, if we're just doing an EG, and I have like thousands of these, so please don't steal it, but if we keep them here, we'll have them all throughout the year as needed. Okay, let's decide what we're gonna reflect. Now we could do like a star and have 10 points. Don't wanna do that. Or we can just do a segment. So check this out. In our notes, I'm gonna go ahead and I'm gonna plot a segment. And I'm not really paying attention to where it is. I'm gonna say this is point A, and then I'm going to go down and over. We'll go to here. There's B. I don't even count. As long as it's a little bit down and to the right. You do not have to count the numbers. Not yet. As long as you're picking that on a nice lattice point, which is where we get that crossovers, we'll be all right. We have segment AB right here. Okay. Now, the line that we're reflecting over, we're going to start with the easiest possibility. I'm going to draw somewhere, I don't know, we'll do it here. I'm going to draw a line L, and I'm going to make sure it's along a vertical line so I can see it really easy. So I'm going to draw a line L, sorry, and I'm going to do it in pencil. Now I'm going to trace this line so it's vertical, and it's going to make it really easy. Here's line L. And hypothetically, we'll pretend like I hit it perfectly. I'm going to reflect over line L. Now, it does not have to be perfect. As long as your points are on a lattice point, which is where the cross happens, we'll be okay. Do you have a second? Yeah, perfect. Okay. Now, I want to reflect this line over. And before we just like commit to drawing it right away, I'm going to do a couple things. I want you to tell me why I'm wrong. So I'm going to try. That guy's uncomfortable too. Okay. I actually need that out a little bit more. Okay. Before I do this, I want you guys to try to reflect it. I want to see what you come up with before I decide if I have to talk about it. Try to reflect segment AB over line L. And I'll come around and I'm going to be judgy for a minute. Try to do it. Tell me where you think it should be. It's kind of ugly, right? Like, the perpendicular distance from a point to the line of reflection is constant. That's kind of a mouthful. But you all, whether you really think you understood what that meant or not, you've all just demonstrated that you know what that means, even if it's not just through the language. So when I came around and looked at your page, there was only, gosh dang it, I'm just going to use this one. There was only a couple little things that I needed and that I was checked for realistically. How could I tell that you were wrong, Carson? How did you know you were wrong? Because you noticed you were wrong also.
Oh, because one was only 1 over, well, the other one was 2
So check this out. If I'm trying to measure the distance from B to my line, is this the distance we're going to measure? No, that's wonky, because then if I gave you all the same picture, we could all come up with different measurements, right? But to be consistent, and you guys did this just naturally, I think, when I draw this, I'm going to measure that way. And I saw Vincent very specifically did this, 1, 2. This is a right angle. That's my perpendicular distance that we're talking about. Now, when we do this, I'm going to switch color. It goes 2 away, and that's all I was checking when I came around. I'm going to pick a darker color. I just went 2 away. Now, notation-wise, we're going to name this point a little bit different. This is my pre-image, point B, and then I reflect it, and here's my image B, right? Now, Lily, just to check, how do you suggest we write this to show that it's been a change? An apostrophe. B, this point right here, goes to this point, which we will read B prime. We go, I don't know why I did that. We go from B, and then we reflected, or translated, doesn't matter, we reflected here, to B prime. Now, my picture is not perfect, but I think that other line's probably about there. This would be point, and we would name it A what? Prime. Cool. Now, just to really stress that, and you don't have to add all this stuff to your picture, because I think everybody in here had this same picture. When we're looking at it, if I take this line that I just drew from B to the line, and I do from B prime to the line, these are congruent. They have to be. They're the same distance. That's that constant distance that I was talking about. Okay. Super doable, seemingly. Do we need to talk any more about just that? Okay. So we're going to bump it up then. We are going to move, instead of just here, I want you guys to, as best as you can, on that graph paper if needed, grab another piece if we have to, I want you to try to sketch a reflection. Sketch reflection. Now, your picture is not going to be the same as mine. Not exactly anyway, but let's go with something that's not too crazy. Let's do a triangle. So I want you guys to draw a triangle of some type. Maybe this is it. I'm going to do mine so it looks like a different length on each side. On the graph paper would probably be easiest. So I'm going to say here's triangle ABC. Now, we're going to sketch this. And I want us to, we don't have to measure like crazy perfect, not the whole time anyway. But I do want you to at least be believable. And we'll check if we need to look at how do we measure stuff. I want to sketch the reflection of this over a new line. And here's where it's going to get wonky. I want it reflected over this line. It's a diagonal instead of a straight up and down. Now, You do not have to, but one of the hardest things, and I might take that back, I might make you do something different. If you're only ever writing in pencil, which naturally you guys are, it is really hard sometimes to tell the difference between the original one and the new one. I have two suggestions. If you reflect these points and then you want to use a dashed line to connect it, that's an easy way to tell it. You could draw a solid one and fill it in, but that could get ugly eventually. Or there's a wonderful collection of colored pencils if you want. But I need you and me, especially on quizzes and tests, to be able to distinguish what's your image and what's your pre-image. Because if they overlap, it's going to be uglier. I'm going to give you guys a second, and I want to see, and I'll draw the same one on mine so I can do it on the graph paper. I want to see what you guys come up with, and if there's issues, where do they arise? Cool. I'm going to give you like a minute or 2 minutes using a straight edge, preferably. I want you to try to reflect this, particularly. Now, with your protractors, if you don't have one, calculator spot number 30, there's protractors there. I would strongly recommend, nay, require you to have a protractor when we're doing these. Like, if it's on a homework and you're eyeballing it, that's okay, but you guys need a protractor right now.
All right, so,
What's that?
right now.
You should grab one now, yeah.
No, I can't.
Yep, because yours isn't right either, and we're going to make it right with a protractor. Okay, so check it out. Basics of protractor stuff. We don't have to measure any angles right now. But if I look at this circle where like I could put my pencil down, you guys can see that there's lines that run through. Okay, if I want this point, I'm going to do point C first. Now what I can do is I can try to line up these lines that run right through 5 exactly with this line. And it's not going to be perfect. The longer the line, the more I can line it up. Like right now, I see that these two right here at the end of my circle line up, and so does my 90. If I go a little bit further so that I can get to the very point C, I think that right now all these lines line up pretty well. Now I'm going to see if I can take my hand off and not move it. Very specifically, what I see is these lines are exactly in line with that pink line that I'm reflecting over. And if I have enough space, and you guys might not, but notice my 90-degree line also lines up. Okay, so as I'm looking at this, I need to scoot it up a little bit so I can get to point C. So I'm just going to move it up so it's on point C. And I'll use that extra line. We'll try to make it look nice. Do you guys agree that for the most part, that looks about right? Okay, now, measurement stuff. If we wanted to use this compass and straight edge, we could, but luckily for us, we have these wonderful things. On mine, I have it lined up at the top. This distance with 10 little ticks is a centimeter. If I see it's 1 centimeter right here, 1.1 centimeter, 1.1, 1.2. I need to then go 1.2 centimeters the exact opposite way. Now, immediately when you guys do this, and I'm going to plot my 1.2, so there's 1.1.2, looks like it's right there. This is my point C prime. If you do this for all three, I don't believe that necessarily anybody in here is going to have the right reflection. We'll continue this tomorrow. No homework tonight. Later, Raiders. Peace out.